India's iron ore mines power our nation's growth, but every minute of downtime costs crores. What if AI could make mining smarter, safer, and more sustainable? Today, most mines rely on manual maintenance and delayed decision making, leading to equipment failure, high fuel use, and wasted resources. Ainsaw introducing MineSmart, an IoT and AI driven monitoring system that tracks machine health, predicts breakdowns, and optimizes operations in real time. IoT sensors collect vibration and temperature data from critical machines. Edge devices process it locally, while cloud analytics predict failures before they happen, using machine learning models trained on historical patterns. MindSmart integrates NodeMCU-based IoT nodes, MQTT for communication, a fast API backend, and AI analytics built with Python and TensorFlow, displayed through a real-time web dashboard. A 1% efficiency gain could save over Rs 100 crore annually across Indian iron ore mines. Reduced downtime means 20% lower maintenance cost, while optimized energy use unlocks carbon credits and new revenue streams. Socially safer conditions and less manual intervention. Economically, reduced waste and higher productivity. Environmentally, lower emissions and smarter energy use. Scalable across India's 300 plus iron ore mines. MindSmart can reshape the mining industry into a data driven, sustainable ecosystem. MindSmart combines technology and responsibility because the future of mining is not just deeper, it's smarter.
Greetings, judges. I will be taking you through our project for the SIH 2025. It is called Shakti Mine, which is an AI-driven digital twin. It is used for increasing energy efficiency in the comminution process in iron ore mining. Uh, as you can see, this is our web application, which shows various parameters related to the mining process. For example, the total power that is being consumed, the total renewable energy percentage that is uh, being generated in this process, the total cost savings that you can get using our web application, using the insights that are available from our application. That cost savings parameter is also shown here, and the fleet health, which means the equipment health, all kinds of sensors, all kind of equipments that are being used for the mining and comminution process. Their health is being consistently monitored by this web application. So as you can see here, there are mainly four system modules that we have created. The first one is for energy management, which is which displays all kinds of parameters related to energy. It's monitoring everything in real time. It's monitoring all the processes. It's even calculating the CO2 production and the overall cost savings with all kinds of energy activities that you are doing. Then this is a visual representation of how you can optimize every process in mining and processes like crushing and grinding using solar energy and wind energy patterns, which are predicted by our AI models. And these AI models accordingly tell you what time of the day, what process needs to be done, and what kind of process will be beneficial to do at what particular time, so that the entire process becomes very efficient. All kinds of data, again, real-time data is being shared in this particular web page. As you can see here, at the end of the web page, there's an AI recommendations uh, tile which shows all kinds of recommendations that our AI engine is giving you based on the data that it has collected from the mining site. For example, the current recommendation is to increase the mill speed to 76%, or the battery discharge is recommended at 6 p.m. to avoid peak pricing, which is this peak pricing uh, has been taken into account by the AI model using real-time data, using the real-time cost price of the energy that is being used. So taking into account all these factors, it is giving you recommendations. Another similar part that we have developed is an equipment health monitor. It monitors health of all the equipments, all the sensors, all the IoT devices that are being used, all kinds of machines that are used in the process. It uses vibrational data, temperature data, and combines all that to predict the health score of a particular machinery or a particular sensor. And it gives you all kinds of details about that right here inside our app. There's a maintenance schedule module here, there's a diagnostics module here, and as well as the sensor trends, or how these sensors react to vibration and temperature. That's also being shown here. This is all being calculated by our backend engine. The next module that I want to take you through is the carbon footprint module, and this is something that we're really proud to integrate into the app itself. The carbon footprint module is important because it tells you how much you are impacting the environment around you, and at the same time, it gives you knowledge and you know it gives you certain ESG rating, and it gives you knowledge about your carbon credits. These carbon credits can be used to identify certain business uh, aspects of the mining process also, because there are a lot of government subsidies, there's a lot of government schemes going on around, which take into account the carbon credits of any production activity. So that is also being provided here. There's a credit summary, there's a carbon credit generation graph, which uh, is made according to the market value. And again, there's a sustainability recommendation engine here, which uses AI to give you recommendations regarding your carbon footprint. Now, the last module is our digital twin module. This is the most important part of the project because because we have used three different laws to curate this module: Bond's law, Rittenger's law, and Kick's law. Uh, all these laws combined, and a lot of physics has gone into this uh, to simulate an actual mining and combination process. So the moment you click on the start button here, it starts generating a graph and starts depicting the real world scenario where you feed the data and you test it right here in the machine before actually implementing it physically and bearing all that cost. It gives you real-time data from the sensors, and uh, everything is provided right into your dashboard here, where you can see power consumption, grinding efficiency, throughput, fineness. Everything is available here. There are certain process parameters that we are using. You can tweak them according to your need. For example, we have feed size, you can increase it and then see the power consumption growing, or the grinding efficiency decreasing, or whatever it may be, based on purely physics. Then our AI optimization will tell you if you need to optimize or not, and accordingly you can uh, continue the process efficiently. So this is our hero product here, and this is the main core idea of our project, the digital twin simulator. Going back, the app also gives information about whatever key features that we have implemented. These are the key features and the technology stack that we have used. I hope we can make a real world impact using this project. And I hope you uh, find it as useful and as impactful as we have. Thank you.